All right, guys, so we're going to lecture a bit in chapter 1. I think in an email I sent out earlier, I said to try to get ahead. Chapter 1 is all definitions. Oh, shit. So what I try to do is I try to develop, with your help, a little story about a research project. So, help me out. Is there something that you would be interested in to know about all Grossmont students? Like the percentage of Grossmont students that like lima beans or something. Maybe something a little more interesting than lima beans. Anybody at all interested? And you're all like, no, dude. Anybody want to know anything? Percentage of Grossmont students smoke, the average age, anything? Or do you care?
Public transportation.
What about it? What percentage of Grossmont students? I like it. All right. So you speak up and you dictate things. That's how this class works. Oh. Everybody got this? 11 to 3:30. We're going to go see where it is, so don't freak out. Some of you guys are like, I've just been happy I found this room. I understand. So we're curious about, now you get to see how horribly I write. Curious about percentage Grossmont students who take public transportation. So get here, I assume. So we're curious about this. This is the way it works in real life. You have something you're curious about, you don't know the reality of it. Now, we're assuming that the administration, if we go to them and say, can you just give us a printout, and they'll look at us and say, no, screw it. So we need to do this entirely on our own. Do you want to talk to all 20,000 Grossmont students? No. I really don't want to. Is everybody with me? So this is how statistics works, right? This is something you guys should come into this class knowing. We have a large group, or we have a larger group of things or people that we want to say something about. But we don't analyze everybody or everything. We take a little sample. I love it, right? Okay, how we doing? So we got a cookie. I don't know what you're doing up there, dude. Take a cookie. No. What's the bigger group called? So take a sample from a population. Crazy. So, population is normally the complete group of things or people that we're trying to describe. By the way, if I ever get to the point where I can't read my own writing, I will retire. I had a teacher that would do that. What'd you write up here? Anybody remember what I wrote up here? I'm like, oh my God, you need to stop. My notes are bad, just do it. So the population is a complete group of people or things that we want to say something about. And the sample is a subgroup of the population. So you could have good samples, you could have bad samples. If I took you, everybody in this room, as a sample to get an idea of this percentage, is that a good sample? No. What, you bad people? No. You're good? Yeah, I don't know. I don't even know you yet. So, but I'm not saying you're bad people, but this would constitute a bad sample. Why?
Because it's just such a small amount.
All right, the size is actually decent, believe it or not. That's a little bit weird to believe. But routinely, for example, how many people are there in the United States right now? Anybody have a rough idea? Holy shit, that's the world, dude.
Oh, in the United States.
In the United States, sorry. We're not quite. We're living on top of each other, like walking on one. I'm on the lower layer of people. Oh, I'm sorry, dude. All right, sorry. Like 350 million. I still remember when it passed 300 million. That was a big thing, and we're just accelerating. Oh god. All right. Routinely, Gallup.com. Anybody ever heard of Gallup.com? It's a great site to go to for polls and information. They use about 1,200 people to do a study. You do not, to represent 350 million people. You with me? And then people that don't know statistics goes, I'm not going to trust that. Well, you're completely wrong. That's fine. So for a 20,000 population, this is actually a decent size. So it's not really the size that matters in this case. What is it about you guys that makes this a bad sample? All right, good, beautiful. That's exactly it, but then we have to figure out what the hell that means. It's not random. Why would that be so important to have a random sample? Why is that important?
Somewhat biased.
All right, without bias. I love it.
I mean, you might have a whole classroom of people with cars. Where
Yes, exactly. Oh, true, but that could happen anytime, right? The problem, stay with me now. Some of you guys, oh man, some of you guys look like you're already, oh shit. The problem with this is, why are you all here? To take this class, right?
Yeah.
Obviously. Would everybody at Grossmont need to take this class? No. So are we, that's one thing. I could keep going, right? We're here at this time. Was there another stats class? Is there another stats class in the intersection? No, that's why I had so many people on the wait list. Well, you could have taken it in the spring, right? Or you could have taken something else during the intersection and taken stats in the spring. You with me? But so, are you representing the population? No. So here's the key aspect. I really want you guys to get to this. Not everybody has to take statistics. Not everybody could take it in the intercession that has to take it, right? They couldn't. Some people just can't take it in intercession, right? Some people are like 4 weeks. You're insane. So we're all insane. It's okay. To be representative of the population, every person in the population has to have a chance to get into the sample. So does everybody have a chance? If I use you guys as my sample, did everybody really have a chance? No. Because not everybody has to, they're not going to take statistics. They're not going to take a class in intercession, right? You guys kind of with me? That's the key. So to be, let me put it here. To be random, oh shit. To be random, let me see if this works. Oh crap in half. These are new. All right. To be, blue. Random. All right, this seems important. Every element, person, thing, every element. Is it very cool if I say element? Every element in the population must have a chance to be in the sample. Oh, you got to write it too, Jeff. And the population must have a chance to be in the sample. That's the word sample, by the way. Okay, does that definition kind of make sense? That's really what random means. So if you watch YouTube, got a lot of people that have no idea what random means. If you don't watch YouTube, that's probably a better way to be. What is it you guys are watching nowadays? Instagrams, Snapchats, any Periscopes? I don't even know if that's around still. All right, so far we haven't done much. We got a big group we want to say something about. We got a small group we can actually handle to talk to, right? Let's go ahead and I'm going to do some of these definitions a little out of order. I want to talk more about the ways to get a sample right now. Let's do this. Let's say you're my population, okay? And I'm going to take a sample from you guys. And I want it to be random. So what's one way to do that? So we're taking a little side note into sampling. What's one way I can get a random sample from this class? Just give me a way. Say again? No. So what I mean is, like, how do I pick the people I'm going to talk to? All right, so beautiful. Okay, so I can start with somebody and then every fifth person after that. What do you think the name of that is? There's a system here, so it's called systematic. So one way to do this, stay with me now. I know you're going to gloss over a little bit because chapter 1 is all definitions, but stay with me. So one way to do it is systematic. Systematic, automatic. Which means start at a random person and then pick every whatever. So really, the main aspect of this is every nth item. Oh my God, Jeff. So what happens? I guess I'm still recovering from New Year's. By the way, congratulations on making it so soon after New Year's. Every nth item is chosen. Why is that random? Remember, random, if I want to take a nice random sample, what's the main thing that has to happen? It's be random.
Everyone has to have a chance.
Everyone has to have a chance to get in. If I started with you and then picked every third person, not everybody has a chance, right? Now, you could argue you could have sat anywhere, but really, the way you are now. If I start with a random person in the first row, just pick a random person, just throw something at the person I hit, is where I start, and then I pick every fifth one after that. Does everybody have a chance? You come with me now. Does everybody have a chance? Yes, they do. Your brain is thinking after I've chosen. Before I've chosen, before I've picked my first random person, does everybody have a chance? Yes. Yes. I'm going to pick somebody random, so I pick you. And then 1, 2, 3, 4, you. 1, 2, 3, 4, you. Right? But I didn't have to start with him. I could have started with the person at the end or the first person. So is there anybody that I would always skip? No, there isn't. You guys see that? So, random is the goal. Systematic is one way to get to that goal. Can anybody come up with a situation where this would suck? This would be a bad thing to use. Do you see how systematic is cyclic? Every fifth. So think about, like, I have this cartoonish image of an assembly line, right? Where something goes ka-chunk, and then it goes shink, ka-chunk, shink, ka-chunk. You with me? And what about the fifth one was defective? Ka-chunk, 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 ka-chunk. So this little dude is not right. You guys with me? So if I take every fifth one, I'm going to start, all of my shit's defective. Oh my God. So if the situation has a cycle in it also, systematic might either always pick up on the bad shit or always miss the bad stuff. So sometimes you don't want to use systematic. Are you guys with me? So like a good situation would be take the temperature every 10 minutes to plot how the temperature's changing. That's systematic. Why? Every 10 minutes. Right? Stop every 7th car and check to see if they've got something they shouldn't have in the car. That's system every 7th car. Okay. All right. What's a whole other way to do this? To get a random sample. The most basic way to get a random sample involves like a hat. Right. And what do you do with the hat? You put
A bunch of names into
all the names of everybody, and then you shake it up and you have people pick it out. Right? Yes? So that is truly just random. There's no... So for example, that's the pick names out of a hat. There's no system to it. There's no process involved. Or putting a list of all the names on the board and just throwing darts at it. And whoever it lands on is, instead of throwing darts out, you guys, long darts, yeah, gotcha, all right. Oh, it's dead. All right, you guys with me? Okay, yes?
So, I don't know about you guys, but when I was little, we did the any, mini, money, no thing.
Yeah, exactly.
Is that
Yeah. No, that's totally, but you can count the number of words, so it's sort of a weird systematic kind of thing, because there's a certain number of words, so it's every blank one, however big the circle you got. And of course, you always had somebody that could add a word here, subtract a word there. Yeah. But What was the bubblegum one? You ever heard the bubble one?
Yeah.
Bubblegum
How many
in a dish,
pieces do
and
you
a
wish?
dish.
And then that adds more randomness to it because the person could say it. And some of you guys are like, what the shit are you guys talking about? Ever heard of eating, eating, mighty mo? There's another one about bubblegum in a dish. I haven't even said that since I was
Johnny
maybe
ate a booger
8.
and it tastes like sugar.
No boogers and sugar. I don't know that one. I don't know that one. You can do whatever you want to. All right. So let me do the third and fourth one because the third and fourth have been a little bit weird. The third one, I'm going to say this is stratified. These are kind of connected, and the fourth one is cluster. These kind of have the same first step, so they get really easy to confuse. What if instead of picking people, I picked rows? I randomly selected rows and took everybody from the rows I picked. Right? So both of these have the same first step. Both of these say break the population up into groups. I've only been about 3 here, but there's 1, 2, 3, 4, 5, 6, 7, 8 rows. Right? So I've broken the population up into 8 groups. And if I randomly select rows somehow, get an 8-sided die and roll it, or whatever the hell I feel like doing. You guys with me? And then I just take everybody from the rows. So I randomly choose the 3rd row, and the 5th row, and the 8th row. So everybody in those rows is in my sample. Is that random? What was it about random?
Everybody had to have a chance.
Everybody has to have a chance. Does everybody have a chance? I love it. See, again, your brain is thinking after the fact. I picked the 3rd row, so you didn't get in. But did you have a chance to get in? Yeah, my 8-sided die could have come up with 2. Is there anybody in here that did not have a chance? And I'm waiting for the person that's kind of like in between rows. Just move your chair over a little bit. You're all right. You guys, is everybody with me? Your brain is evil sometimes. We're hardwired to not understand some of this stuff. Your brain says, I didn't get picked. You had a chance, though. That's the key thing. You can't pick everybody or else the whole thing goes to shit. I don't want to talk to 20,000 people, right? So cluster is the one I was just talking about. Cluster would say, randomly pick 2 groups or however many groups and take everybody. So all from some. A very Three Musketeerish sounding thing. All from some is cluster. That makes sense. What's cluster mean? There's a cluster here and a cluster there. So you take entire clusters. How are we doing so far? Another way to do it is, so some rows could say, well, you didn't represent my row. It's sort of like how Congress works. You want to represent all the states and all that kind of business, right? So what do? We don't just pick certain states to have people go. We take every state, but we take some people from each. So if I took if I randomly selected 3 people from every row. So I still break the rows, I still break the population up into groups, 8 rows. But now instead of taking entire rows, I take some from each row. So this key phrase is some from all. Some from all from some. Sounds very musketeerish, it does. Notice how stratified, some from all, cluster, too bad, but at least stratified it says. How we feeling? Those approaches, you've heard of them before.
So you're taking some from all rows for stratified.
Stratified. So if I had a high school, and I took like 50 freshmen, 50 sophomores, 50 juniors, 50 seniors, that would be stratified. If I took all the freshmen and all the seniors, do you see how I wouldn't want to do that? Because then the juniors and sophomores are like, we don't mean shit. And your seniors would be like, no, you don't. Yes?
So on the test, would you give us like an example and we have to guess like which?
Yes, so I never make you define something directly. That's shit. I make you use the word correctly or identify a situation. Yes?
Could it ever be, I'm sure it could be, but like multiple in one? Like could it be?
Yeah, and I try to stay away because it gets a little weird when you have, what if you took some states, but then you took some people from each state?
Yeah.
That would officially just be random. So like taking some things from one hat, that's random. If I had 7 hats full of names, and I took some hats and I took some stuff, that's freaking random. That's like putting all the 7 hats together in one giant ass hat. Right? Do you see what I'm saying?
Yeah.
So you'd think that's a mixture, but then it just becomes random because there's no real order to what they're doing. Yeah. All right. So I try to stay away from, try to make it a little clear cut. Okay. And there's one last one, the sucky one. There's one really crappy way to do something. So for example, if you went to a mall and stood outside. I don't know, some store, it doesn't matter. And you started just asking people, so what do you think about this store? What do you think about this store? That is no good. Why is that no good?
Annoying.
I mean, so if you stand outside, like, do you guys even have Spencer's here? I mean, yeah? All right, stand. So poor Spencer, this is weird shit. But you stand outside Spencer's, and as people walk out the store, you're like, what do you think of this store? How would you rate this store? Okay. How would you rate this store? What's kind of wrong with that?
I don't know, what if they're shopping for something else?
Well, not that. What's wrong with the way I'm collecting my data?
We're already in there, so we don't have to
Yeah, there's sort of like inherent bias there. I didn't even try to represent, what population am I trying to get at? Well, like I'm getting at the population of San Diego. Well, does everybody go to that store? Plus, you got the bias. They're in the store. It's very unlikely they don't like it. Right? A few of them might be like, that's the first time I ever stepped foot in there. That's some weird ass shit. I don't like this store. All right. Don't come back. Right? You guys with me a little bit. This is called convenience. This is if I used you guys as a sample to represent all of Grossmont. Is that not convenience? Have I done any work to ensure that it was random? I've done no work. Right? That's why it's called convenience. So that's the last one we talk about because it's just a shit show. You could accidentally get a really good sample, but you just don't know. You've made no attempt to make it random, so if you do any studies from this, I'm going to throw it out.
So you made the high school reference for the stratified. So you were going to do a cluster for the high school. You take all the 7th graders and all the 8th graders would leave the...
All the like freshmen and all the juniors,
Oh, yeah.
and nobody from the other ones. See, in that case, that'd be a bad thing, because then if it's some like rule they want to make, then the other groups will be like, we are not represented at all. It's sort of like saying, okay, Massachusetts sent some people, but New Mexico, nobody from you. And we're going to set some tax laws, right? And so that's the thing. They got to throw some tea somewhere and shit like that, right? Taxation without representation. All right. Stats class, Jeff. I teach you history. You're going to all fail history. Okay. So let's come back. That was a little side note. That is in section 1.3, I think, is where these are. I don't know. They're somewhere in chapter 1. How we doing? You all right? Today I'm gonna talk a lot more than normal, just because there's a lot of frickin' definitions to get through. All right. Okay. So coming back to our, let me not erase these. Everybody got these here? Okay. So coming back. So, that was a little side note about how to pick samples. So let's say, all right, this is our population. We take stratified from every row, whatever. What do I want to do next? So I got my sample of people. What's the very next thing I'm going to do? Why did I collect them? What am I going to do?
Ask them a series of questions.
Ask them some questions, right? And I'm obviously going to ask them, do you take public transportation? Right? You with me? All right. I like it. So there's when I have a sample and I analyze it, remarkably enough, the number I come out with. So let's say I get a sample of, let's say 30 people, and I get 18 use public transport. Can you calculate anything from that information? Hopefully, because we just had a problem just like that.
What percentage?
Yeah. So it would be 18 out of 30, which you could use a calculator for, but just divide both by 3 and you get 60%. Cool. I like it. So what the hell is that? Is that the answer to this? What is that from? A sample. All right, so that has a word to it. The thing I'm trying to get at, the thing that talks about the population, which I'll never know, right? I'll never know the reality because I'm using a sample. I never know the real thing about the whole population. So this is called the parameter. The parameter, you're on the splash show, by the way, sorry. The parameter describes the population. You gotta love this shit. The other word's also gonna go along too, so just accept that when it happens. Parameter describes the population. It's normally either an average or a percentage, but there are other things it could be. So it's some numerical, let me make it even better. Numerically, if I want to make this grammatically correct, numerically describes the population. Parameter describes the population.
Average or what?
Percentage, sorry. I still want to write the whole word. The less I write, the better. And this thing here, this, is called a statistic. Yay, there's a word, that's the thing of the name of the class. So what we just calculated, 60% is the statistic because it just describes the statistic describes a sample. So don't make a mistake on that shit. Parameter, population. Statistic, sample. Everybody with me? So that would be, it's a numerical description of a sample. So if I said 60% of all Gross 1 students take public transport, what is that? Which one? 60% of all Gross 1 students take public transport. Which one is it describing? Is it describing the population or a sample? 60% of all Gross 1 students. So it's a parameter. So what's kind of a key word that doesn't always show up, but when it does, all, holy shit, all is population, right? If I said 73%, the answer is going to be statistic, obviously. But if I said 73% of the 80 people I talk to like sushi, that's a statistic because it's of a sample. Everybody with me so far? Not too bad, right? You guys look really beat up, I'm sorry. All right. So, let's talk about, let's go back a step. So this is what I want to say something about. That's a parameter. This is the group that I can actually talk to and do something with, and that leads to a statistic. And for example, later this semester, anybody in here pay any attention at all to polls? We just had a midterm election. I'm not going to ask you if you voted, because I just hope you do vote, pay attention. If you can't vote yet, still frickin' pay attention and be ready, right? Did anybody look at any polls about what percentage are going to vote for this proposition, right? Or what percentage are going to vote for this person? Anybody look at any polls ever? Yes, yes. All right, one of them. All right. And the rest of you are like, of course, just get to your point. So very often what they'll do is they'll say, is that still going? Poor little dude. Yeah. What you'll see is like 44% will vote for will vote yes. 42% will vote no. These don't add up to 100. Why? Undecided. And then at the bottom it says plus or minus 4%. Have you guys ever seen that?
Yes.
There's a mathematical way to get to this number. It isn't just them going, man, you could be wrong. Say, give or take 4? No. This number will go down if you increase your sample size, for example. If you make your sample bigger, then you should have less uncertainty. So there is a formula that has sample size in it. right? For example, it's got a lot of other shit we'll learn. We don't know it yet. But we're going to learn the formula that gets us to that number. Now, what does this mean? This looks like yes is going to win. And unfortunately, people don't understand this, and they'll stay home. I wanted to vote no, but there's no chance. I'm just going to stay home. But plus or minus 4%, no could be ahead. Right? It could be 46 to 40. You guys kind of with me? So that's just one example of how not understanding how to interpret this kind of stuff leads to true change in an election. If fewer people vote because they wanted to vote for this and like there's no way I could win, then you're definitely going to make this one win. You guys with me? A little bit. Okay, that's just one example of how not understanding something like that can actually change the results of something. All right. So, let's come back to something that's going to lead us to another little side note. And then I think we'll take another break because you guys will go and you can use it. All right. So, help me out. Going back a step, once we got our sample, you guys said we're going to ask them questions, right? Those questions are related to what we call the variable. What does variable mean?
Thing that can change.
Something that can change. The values of the thing can change. So obviously, if I ask everybody in here a question like, how old are you? If everybody said 22, that would really, really freak me out. Right? Especially because I know some of you guys are not 22. Right? Some of you guys are not quite 22. So that's why we call it a variable. The question, how old are you, means the variable is age. Because the answer will, of course, change. So in a problem, if it says, what's the variable here? Think to yourself, what would I ask somebody? That's the variable. So the variable is related to the question you would ask. No, not question, Jeff. Now, obviously, if you're doing a study about the height of trees, you're not asking the tree, how tall are you? So when I say the question asked, you would ask it. Just mean what you're trying to get an answer to. Right? The answers to the question are called the data. Not surprisingly, right? If I walk around and say, how old are you? How old are you? I'm going to have a list of numbers. That's my data. I can then do shit with it. What's the average age? What percentage are less than 21? Whatever. All right. So we're going to deep dive into data for a bit. Variables and data. So everybody got this board's worth of stuff? I think so, yeah. All right. So a little side note about data. Let's talk about variables first. Types of variables. You have a qualitative, got it, or you can have a quantitative. No, Jeff. Somebody teasing it. Quantitative, yes. What's the root word of qualitative?
Quality.
Quality. And what's the root word of quantitative?
Quantity.
That's crazy. I love it. Sorry. So obviously the quantitative quantity is truly numerical. Right? Truly numerical. What does that really mean? It means it's stuff I can do stuff with. I can subtract them. I can do stuff like that with them. I can do number stuff with them. So for example, if I ask you what zip code do you live in? All right? Do you guys know what zip code you live in?
Yes.
What zip code do you live in? what zip code do you live in? Now, if I subtract those, do I get a number? Does that mean shit? Does that number mean anything? No. So like you're before her, so yours is better. No, that doesn't mean shit, right? So are those really numerical then? No. Do they represent a quantity of something? A zip code? What about your social security number? Right? You can subtract those, but they don't mean anything. What about your jersey number if you're on a team? Right? I'm 73 and you're 70. I'm better than you. Right? I won already. Let's go home. No. So qualitative are categorical stuff. Like names, like hair color. Stuff that's not numerical. Descriptive. In a non-numerical way. I don't know how else to say it. So you can describe somebody's hair color with a word. You can describe... Now see, like, temperature is interesting because you could say it's a hot day or it's a cold day. That's a little more qualitative, but then you can say it's 70 degrees today. That's quantitative, right? Yeah, I like the take, maybe. So that's not that bad, right? That breakdown. One is truly numerical, meaning you can do number stuff to them and it makes sense. You can subtract them, you can add them, you can divide them, whatever. Qualitative is just names. Okay. So let's break this down. Just for fun. There's 4 levels of hell. Quality. There's more than that if you read Dante. There it is. The first 2, I don't know why I'm picking on quantitative. It's both of these. The first 2 are related to qualitative. So 4 types of data. So the first one is just what's called nominal. Everybody gets this wrong. Let's get this out of the way right now. Nom has nothing to do with number. No. Anybody have any idea what nom?
Nomination.
Sure. Sort of.
So like,
Anybody ever heard the phrase plume de nom? Pen name. So nom is name. Nominal is just names. That's all they have. Like hair color. There's nothing extra about them. Do hair colors, if I listed the hair colors in here, if I listed, I see some blonde people out there, some brunettes, some redheads. So if I put redhead here, is anybody going to go, oh, you put them out of order? There's no order to them even, right? Just names. That's nominal. Now, if you add on top of that an order they want to be in, that becomes this next thing which kicks ass. It's called ordinal. It just gives itself away. What could ordinal be? Order. Oh, okay. So ordinal. So what kind of things are names, but they also have an order they need to be in to make sense? Months. I love it. Kick ass. Yeah. Right? If I started going, what month were you born in? March, February, October? What's wrong with you?
years.
Yeah, years. Okay, I like it. So, where would Social Security number go?
Ordinal.
Interesting.
Well, because if you don't have an order, then you don't have social security.
So they are given in a certain order. But I don't know if you guys know, like the first 3 of my social, I'm not going to give you the whole thing, is 258. Everybody else have 258. 258 means I was born in Georgia. And nobody else born in Georgia? Maybe they gone on. Nobody else is born in Georgia. I'm the only one. It's my state. Yes. Anybody born in California? All right, what's the first 3 years? 65? 614? 614? All right, California's huge, a lot of people, so they had to kind of split it up into a few. You guys with me? But the first 3 of your social relates to where and when you were born. Anybody ever know that? I didn't know that until I was 20-something or other, and somebody's like, oh, you were born in Georgia. I'm like, who the shit are you? Right, David playing again. Oh, no. that really freaked me out. Anyway, so you can argue either one, to be honest. So there will be times when, depending on how you look at it, it could fit in either one. So when I ask this kind of question on a quiz or a test, I always say explain. So the real grade depends on how you explain your answer. Now, if I tell you Social Security number and you say, one of the next two, you're going to be wrong, because the next two are going to be truly numerical. So normally, there might be some that have one or two that they could be. You just have to explain it correctly. Ordinal means it's names with an inherent order. What does inherent mean?
Like something that's like naturally given or something like that.
Yes.
Yeah.
Intrinsic. What does intrinsic mean? Inherent? No. So do cars, if I made a list of cars, could I put them in alphabetical order? Of course. Must they be in alphabetical order or else they don't make any sense? No. If you go to a restaurant and they ask you to rate the service and they put good, poor, excellent, fair, what are you going to say? You're like, what are you trying to do here? What are you trying to do? That's not the right order, right? It's supposed to go from like worst to best or the other way around. There's got to be an order to it. Everybody ever filled out evaluations, faculty evaluation, they have to fill in the bubble. So they flipped around, oh, do you agree? Do you strongly disagree? Do you strongly agree? You're like, what are you guys trying to do?
Gas
What?
stations do it too.
What do they do?
Like if it's 85, 87, 89 or whatever, they'll flip them so you don't
Oh
have to
shit!
scroll
You're
up.
right. I've done that. Yeah.
So
And
annoying.
most of them are in this way, and then the other somewhere flipped it. I'm like, what are you trying to do to me? All right. So just because you can put something in order doesn't make it ordinal. There has to be an order that it needs to be in. Are you guys with me? Okay. So those two are related to qualitative. We'll do these next two, and then we'll take a break. Okay.
Qualitative or both of them? Is that for both of them or just qualitative? The first two?
First two are qualitative, because these are not numerical, truly. The next two are going to be truly numerical, and you'll see why immediately. I'm going to put both of these down. One is called interval, and the other is called ratio. Ratio kind of gives itself away. What operation does ratio seem to imply? Give me a ratio.
Like 2 parts water, 1 part flour.
Sure, which means you can make it 4 parts water to 2 parts flour, right?
Yeah.
So you can increase or reduce. It means you should be able to divide. So ratio implies division. So interval, what's an interval? What the hell's an interval?
Change.
So something could change over an interval. Give me an example of an interval.
It's like a time period.
Sure, there could be an interval of time, right?
Yeah.
An interval of space. Well, I don't know. Trying to make something up. Interval of time is the one that we're most used to, right? So interval. So you can talk about how long an interval is. So from 10 minutes to 20 minutes, how long is that? From 10 minutes to 20 minutes, that is. I love sitting guys on. Yeah, I'm not even going to answer that question. I like it. So an interval, it means they are data points that you can subtract and the answer makes sense. That's the key thing. Can I subtract 2 zip codes? Yes. Does the answer mean anything? No. So interval means subtraction of data points makes sense. One semester, I had some people that were on the women's basketball team, and I said, now jersey numbers, are they interval or ratio? I'm sorry, are they interval or are they, where would jersey numbers be? Nominal. Yeah, there's not really an order to them, right? Number 12 isn't any better or worse than number 10 or whatever, right? They aren't interval, I said, because if you subtract somebody from another jersey number and jersey number, the answer doesn't make any sense. Now, unfortunately, one jersey number was 14, the other one was 10, and then the third girl, her number was 4. And I'm like, if you subtract your jersey and your jersey, you don't get, and they're like, we get her. I was like, shit. But normally when you subtract nominal things, they're not going to make any sense at the end. You'll get a number, but does it mean anything? No. You guys understand what I'm saying? So don't just tell me, yeah, you can subtract 2 zip codes, so that's the interval. The answer doesn't mean shit, right? Ratio, like I said earlier, it's kind of a two-parter. Division makes sense. Division of 2 data points makes sense. And 0 means what it should. What should 0 mean? None. So, how many temperature scales do you guys know?
3.
Some of you guys know 3. Some of you guys know 2. The 2 main ones are Fahrenheit and Celsius. They relate to metric. Do you guys know Celsius does? Do you guys know we're the last country on the face of the earth to not use metric? It used to be 3, and the other 2 wised up. We're America, though. We don't believe in that kind of shit. Sorry. Well, move out of here, shut. So there's Fahrenheit, Celsius. The third one I'm not going to talk more about than just what I'm about to say is called Kelvin, after Lord Kelvin, excuse me. And that's the one that measures the amount of energy in something. So with Kelvin, 0 means we're all dead. Right? That's what's called absolute 0. You guys have heard of that term before. I did some research at my university that were cooling atoms down to close to 0, and they would all kind of like overlap like cookies, and we were pushing it around. It's neat. Sorry. So temperature. The normal temperature we talk about in America, Fahrenheit, right? What does 0 degrees Fahrenheit mean? Can you not get colder? Of course you can. I know we live in San Diego, but you are aware that 0 exists, number 1. You're all like, I didn't know less than 30 existed. So 0 doesn't mean what it's supposed to mean with Fahrenheit. The absence of heat. You can get colder. So that's one reason why temperature is interval. Fahrenheit is interval. Because 0 doesn't mean what it's supposed to mean. What's twice as hot as 0 degrees? There is something that somebody go, it's twice as hot. Yesterday it was 0, and it feels twice as hot today. Right? Couldn't somebody say that and it kind of makes sense subjectively? But mathematically, does it make any damn sense? What's twice 0? Freaking 0, right? So division doesn't make any sense for temperature. What's twice as hot as 60? Not 120, right? If it was 60 one day and then 78 the next day, you might be like, it's twice as hot as this thing. And it would subjectively make sense. Mathematically, it doesn't make a damn bit of sense. All right, how are we doing? You guys all right? Yes? Okay. Was there something else I want to say? Let's do this. Let's take another break. Let's make this one 15 minutes. And then when you come back, we'll do some examples of this and some of the other stuff. And then we'll see how much time we got left. So come back. Let's make it 11:40. Come back at 11:40. Okay.